I'm Mr. McBrien. This is Arduino 8, communicating with the user. Yesterday we talked about sensors and the Arduino detecting the world around it. Today we're going to talk about essentially the opposite, the Arduino communicating with the end user. So communication so far with the end user, I'd invite you to stop for a second, pause the movie, and think about how is the Arduino communicating with the user right now. So, welcome back. If you gave it a bit of thought, you'd realize that the serial monitor is how the Arduino has been communicating with us as we've been developing our sketches so far. And this is appropriate during development of a given device. However, there are very few Arduino implementations where the device is connected to a computer while it is operating as part of its final implementation. Now, we should probably ask ourselves first, why do we need the communication between the Arduino and the user at all? And there are several good reasons for this. One is we want to be able to tell the user if there's a problem of some kind. We want to be able to prompt the user for input if it's that kind of device. We want to give status updates. So the Arduino might want to communicate to the user the process that is currently being undergone. Also, while so far we've been looking at the Arduino debug process, the development process, the communication through the serial monitor, there can be situations where as we're developing our prototype devices, we may not be able to have it connected to a computer. That is, we won't be able to use the serial monitor, but we still want to be able to get communication to the user of what is going on. So in all those cases, we need some other mode of communications beside the serial monitor. So I'd invite you again to pause the movie and think about how the devices you currently use today communicate with you. And I'd invite you to move past the phone, which is really just another computer, and think about other devices, less versatile devices, and how they communicate with you. So go ahead and pause and think about how those devices communicate. Okay, welcome back. So in terms of ways that a device might communicate with you, you might have thought of indicator lights telling you that, for example, that a device is under power or it's been powered up. You might have thought of buzzers, those annoying things that come up when something goes wrong, typically. If you thought of your car, you may have thought of the idea of a dial. Digital readouts are a common way to communicate to the user. And of course, screens that may not be quite as elaborate as those on our phones. Now, did you think of anything else? There are lots more, in fact, ways to communicate for a device to communicate with a user. Having said that, the most important modes of communication are probably shown here, and we can discuss each of these in turn. Okay. So to start with, indicator lights, we've already worked with these. Now, initially you might say to yourself, there isn't a lot that can be communicated by a simple LED. And in fact, that's not really true. The level of complexity of the communication is up to us and our implementation. Of course, we can have our lights turn on and off. We can have different color lights, or we can have a single light, but it's an RGB LED, and so we can change the color of that one light. We can have patterns of lights, combinations of lights that might that might communicate. So let's not forget about our beep codes from our computer. We can communicate with Morse code, for example. So I would say that most simple Arduino implementations can be completed with LEDs as the primary communication device. We can communicate with the user using a simple LED, and this has tons of advantages. Now, for the cases where that's not feasible, we can use some other modes of communication. A common one would be a buzzer or a speaker. Now, you might say to yourself, what's the point? An LED can do just as good a job as a buzzer. So think for a second, what's the advantage of having sound? Where have you seen sound implemented in a communication device? Well, you may have thought about the idea that if a user's not looking at the device, then sight isn't a good communication mode. So alarm clocks can't use as their primary communication light because your eyes are closed. Similarly, it may not be effective to use light in a primary communication for a backup camera because you might not be looking at that light. You may be looking in, for example, a rear view mirror. So the advantage to those sound-based communication devices is in fact that you don't have to be concentrating on them for them to alert you to something. And similarly to the LED case, we can vary whether our buzzer is on or off. We can make the volume higher and lower. We can put in place patterns, those beep codes again from our computers. If we implement a speaker, in fact, the Arduino supports the idea of using tones, so we can communicate through musical notes. With a buzzer, though, we can't do this. The buzzer has a set frequency that it rings at. Okay, dials are a very common communication device in a car because at a glance you can see given ideas. They're not typical in Arduino implementations, and the reasons for these kinds of dials are expensive, they're delicate, and they do require a power source. So they're not a typical implementation. Typically, we will find with Arduino that it's easier to just use a digital readout. And in fact, you may have noticed that many car manufacturers have come to the same conclusion with their dashboards. Okay, so those digital readouts, Alphanumeric Displays, we have a very simple, tried and true piece of hardware available to us called a 7-segment display. And using this, we can easily communicate, especially numbers. If you want to communicate a simple number like a countdown, these can be extremely effective. Inexpensive, compact, lightweight, very robust. Now, on the other hand, if you want to communicate something more elaborate, you may decide that you need one of these nifty LCD displays where you can communicate text strings. This tool is tried and true, very effective. However, it's going to add some size and weight to your device, and they're not precisely cheap. Instead of pennies for an LED, you have dollars for an LCD. Now, so we've spent a fair amount of time talking about alternatives and different needs for communication. When it comes time to design your feedback system for your implementations, what you want to do is first think about what your implementation needs. You don't want to over or under design your communication with your user, or your device will be too expensive, too complicated, or unusable. So ask yourself, how much information does the user really need from the Arduino for it to do what it needs to do? What types of information does the user need? Is it a status? Is it a number? Or is it something more complicated? Ask yourself what type of communication is practical. If the user is asleep, then light-based communication is not practical. Also ask yourself how often the user is going to need information, whether it's once in a while or whether it's all the time. And think about how much documentation can take the place of that complicated LCD screen. So if you only have, for example, 4 different possible communications with the user, that's more likely implemented from a color LED or 4 red LEDs rather than an LCD screen. And then the user needs to simply check the documentation, whether the documentation is on the packaging of the device or in a little book. But keep your system as simple as you can. You want it to be lightweight, you want it to be cheap, you want it to be easy to implement. The less, the better. Okay, so key points in our communication discussion then. The Arduino can communicate various ways with users. The different applications, the different devices are going to suggest different approaches of communication. And if we can call it that, the correct implementation depends on the use case, the situation involved. But first and foremost, keep it simple. Okay, so I've included a few references. One for talking about tones. The RGB LEDs are fun to work with, the 7-segment display, and the LCD screens. You can, of course, do a Google search to find help with any of these things, and there's lots of great references out there. So for your homework, what I would like you to do is work on that final project. So your indicator portion of your backup safety system, then, you now should have the ideas you need to communicate back to the user what's going on. Okay, I hope this helps. Thanks very much, and have a great night.